Assalamu alaikum warahmatullahi wabarakatuh. Karibuni tena kwa channel yetu. Nimesema kwa vile most of the students were really requesting nianze pia kufanya papers za chemistry, so nikasema wacha pia nianzie, but originally obviously I'm a chemist, math and chem teacher, so obviously I think from today I might think of uploading chemistry content as well. So I'll be uploading 3 contents: maths, chemistry, Arabic, and very soon maybe business as well. Okay, question 1. Kama kawaida, section A, theory part. There's also section B, which I think is the practical part. But I don't know whose idea was this. Oh, I've understood. Section A, theory. Answer all questions in this section. Question 1. A grade 10 learner of Mango Senior School notices that fertilizers improve crop yield. Tamam. Medicines cure diseases, fuel produces energy, and plastics are used in daily life. So using the above scenario, define chemistry as a field of study. Then that's the first question that you need to ask yourself. What is chemistry? Tamam. Now, to me, chemistry is a branch of science because science has a lot of branches. So chemistry is a branch of science, okay? Because also physics is a branch of science, biology is also a branch of science that deals with, okay, or that studies matter. Obviously, physics also studies matter, but this one, chemistry, studies the composition of matter, how matter is composed, or what is it composed of, which substances does it come from, the structure, how it looks like, properties, okay, properties, how does it behave, is it colorless, or does it have a smell, and the changes it undergoes. So I'm repeating again. Chemistry is a branch of science that studies matter, composition of matter, structure, properties, and the changes it undergoes. So that is chemistry. Now, question B, explain 4 roles of chemistry in daily life shown in the scenario. Remember, chemistry, if someone tells you what is matter, matter is anything that occupies space and has mass, right? So when we look at matter, there's different forms or sub constituents of matter. We have solid, we have liquid, we have gas. Now, how are the solids what are the solids composed of? Is it made from atoms, molecules, compounds, and etc.? Structure. Does it have a hexagonal structure? Does it have a pyramid structure? Which structure? Properties. Does it have a smell? Is it black? Is it white? And the changes it undergoes. What happens if you take one substance, react it to another substance? So that is chemistry. Now, the roles of chemistry in our daily life include: first one, manufacture of fertilizers, which increase crop yields. So without chemistry, we can't make those fertilizers. Second one, medicines. Okay, most of the medicines are made from the knowledge of chemistry. So medicine cure diseases. So without chemistry, you cannot make medicines. We also have fuels. If you study further, you'll study something to do with organic chemistry. That's where we get our fuels from, hydrocarbons. So again, without chemistry, we cannot manufacture fuels that provide energy. Energy to make the cars move, energy to make the rockets go out for space, and etc. Then we have plastics. Now, plastics obviously are used in our daily life, storing water, in many things. So without that knowledge of chemistry, you cannot create plastics. And plastics come from the knowledge of hydrocarbon, something to do with polyesters, polythene, or and etc., which you'll study it further. That's another lesson to be discussed once you enter grade 11 or maybe grade 10 as well. Tamam. That's question 1, but we haven't finished. This is question C, 1C. State 3 reasons why learning chemistry is important to society. First of all, it improves agriculture. Basically, if you have fertilizers, then we can able to make those, you can able to increase crop yields, and as a result, improve the agriculture of the nation. Second thing, since we create medicines, then we enhance the healthcare of our nation. Okay, enhances the healthcare. We make the health of the others more, how do I say it, more good. Okay, so we enhance the healthcare by creating good medicine, better medicines, and quality medicines. Another thing, we provide energy solutions, especially when we create fuels, fossil fuels, and etc., hydroelectric power, and a lot of types of fuels. So provides energy solutions, electricity, fuels, fossil fuels, and etc. We also have other importances, especially you can improve industrial development. You also invite, what do you say? It supports environmental protection. Support environmental protection by thinking of things that doesn't affect the environment or don't pollute the environment. So supports environmental protection, or by creating substances that do not pollute the environment. Support environmental protection. Okay, so that's question 1. Let's go to question 2. Now, for question 2, during a career guidance session, learners research different careers related to chemistry using books and internet. Question A, name and describe 4 branches of chemistry. So the first branch that we need to know is organic chemistry. And now organic chemistry tends to deal with organic compounds, that is anything relating to carbon. So studies carbon compounds, especially the hydrocarbons, the alkanes, the alkenes. So anything to do with carbons then is under the branch of organic chemistry. So studies carbon compounds. Okay. Then since we have organic, then it means we have inorganic chemistry. And now inorganic chemistry, we tend to study non-carbon compounds. Studies non-carbon compounds, especially the S and P block elements, like for example sulfur, nitrogen, and other elements. So anything that doesn't deal with carbon, let's take an example, oxygen, nitrogen, then is under inorganic chemistry. So for potassium, sodium, chemical families, all of them are in organic chemistry. Another branch is that one that you know is physical chemistry. So a little bit of physics is applied here. Okay, physical chemistry, and no, doesn't apply physics, but sometimes, yeah. So, but physical chemistry studies physical properties and chemical changes. Studies physical properties. Okay, how does it smell? What is the nature of that substance? That deals that's under physical chemistry. So physical properties and chemical changes. Now, the fourth one is analytical chemistry. Okay, analytical chemistry, analytics. You just look at how the substances are. So under this, you just study the substance composition. So it just deals with studying of substance composition. How is it made of? What is it made up from? And etc. How is it composed? In short, so it's like, I think everyone knows what analytics mean. Yani waangalia analytics yake vipi, intengenezwa vipi, and etc. We also have other branches as well. We have biochemistry. Biochemistry studies the chemical properties that happen in living organisms. In living organisms, the chemical properties like respiration. We also have photosynthesis. It involves biochemistry as well. So any chemical properties that usually happen in living organisms, then the branch is called biochemistry. Then we also have environmental chemistry. Environmental chemistry deals mostly about the environment, how to make the environment good with the help of chemistry. So studies environmental pollutants. So yeah. So question B. State 3 career opportunities related to chemistry. Is a lot. We have chemical engineering. So you can become a chemical engineer. Now you might be asking yourself, who's a chemical engineer? Research on that. You can become a pharmacist. Tamam. You can become a lab technician or laboratory technician. You can become a chemistry teacher. I don't know why people don't like that, but I find entertaining. You can become something. There's a profession called forensic scientist. Okay. There's also environmental chemist. You mainly look at the pollutants that are affecting the environment. Environmental chemist. We also have a food critic or food technologist. Food critic is a different case. It's called food technologist. Especially companies like KEBS deals with this. You look at the quality of the food. Is it good for human consumption? What things are in that food? Does it have a high concentration of calcium? Does it have a less concentration of minerals? So that's called food technologist. So yeah, very easy. Now let's go to question 3. Question 3. Grade 10 learners of Kilgoris Boys Senior School discovered that chemistry plays a major role in different industries such as agriculture, pharmaceuticals, food processing, energy, and entertainment. Question A. Explain 4 applications of chemistry in the following areas. Agriculture. So how do we apply chemistry in this field? Most of the time we use chemistry to make fertilizers that increase the crop yields. You also use pesticides to remove the pests, or to, what do you call it? To spread or to remove the pests around the fields. so we use pesticides. Pharmaceutical industry, how to apply chemistry into that. Okay, now pharmaceutical industry, how do you use chemistry in this industry? We make drugs, or we form drugs, so it's called drug formulation. Manufacture drugs that usually used in curing diseases, also preventing diseases, can be used to create antibiotics, curative drugs, and etc. So drug formulation. The third one is manufacturing industry, application of chemistry. That is, and for the manufacturing industries, a lot. We create soaps, we create plastics, we create paints that usually are manufactured in those industries, and etc. Also have iron sheets and etc. Entertainment industry, I think this one you know. So we apply chemistry to create fireworks. Also, I think dyes as well, dyes and pigments and etc. Uh, Someone might ask, how is dye connected to entertainment industry? Obviously, we use it. What do you call it, for makeup and other purposes? So yeah. So let's continue. Question B. State two benefits of chemistry to economic development. Okay, improve or enhances industrial development. So yeah, that's one thing. Or industrial growth, enhances industrial growth, especially if you make a lot of things, you have a lot of industries. So yeah, so in that it enhances industrial growth. Okay, that's the first, and that's the first thing. The second thing, obviously, job creation. Job creation. You may have job creation like chemistry teachers, we have pharmacists and etc. So yeah, job creation. We also have technological development. We use chemistry for technological purposes as well, technological advancement. We also have exportation of goods or of chemical products. So if you create or if you form a drug, then you can export it to other countries. So export of chemical products. Okay, so now let's continue to the other question. Question 4. A health officer warns learners about the dangers of drug and substance abuse in schools. Question A. Define the following terms. What's a drug? Now, a drug, many students might think this one, but to me, a drug is any substance, okay? Any substance that alters the body functioning when taken in. How the body functions. So it can alter in a positive way or a negative way. The body functioning when taken in. So you can take it through oral or through injection and etc. Taken in or through smoking. But also many people uh, connect drug to medicine. So a medicine is a drug, but not all drugs are medicines. Okay, so many students can think a drug is anything that treats or prevent diseases, which to me I think is very wrong. Roman 2, prescription. Now prescription is just an instruction from a medical profession, okay, from a medical or from a medical health profession or professional or a doctor, okay, or a doctor, but most of the times for medicine. for medicinal purpose. Okay, it states how much amount of medicine you should take, what time should you take the medicine, and etc. This mainly explains about the dosage. Okay, but remember, it's not an instruction only. Most of the times, a written instruction. It can be an oral instruction sometimes if the doctor says so. Now, but mostly it's a written instruction. Dosage. A dosage is the quantity and frequency quantity and frequency of taking a medicine. So how much should you take a medicine? Especially you may get, for example, you may get like this from your medicine, 3 times 1. You take three tablets once, or maybe 1 times 2. Take 1 tablet 2 times a day. So the frequency is the duration, and the quantity is the amount. So yeah, it's not that hard. Now, question B, explain 3 effects of drug and substance abuse on learners. First effect is addiction. You'll get addicted to it. Okay, so once you take in those drugs, or if you abuse those substances, you're just getting that addiction part most of the time. So we tell students to stay away from it. Another thing is poor academic performance. So sometimes waweza ukapagawa tu, wachukua bangi, lakini ukaona hauko duniani, uko somewhere else, huko labda majuu. Okay, there's the risk of accidents, especially when you're taking alcohol while you're driving. This risk of accidents. Okay, and there's many. There's also social problems between the husband and the wife, leading to divorces. Sometimes you can quarrel with the neighbor or the society as large. So that's why I always advise my students not to be involved in any of those things. So yeah, that's question B. So that's question B. Question C. State 1 responsibilities of learners in promoting a safe and healthy learning environment. One responsibility. There are many. There are many responsibilities, but one, always avoid those substances. First thing, avoid drug use. Avoid those drugs. So once you avoid it, your friend will also avoid it, and also report drug abuse or drug use. So report drug abuse or any abuse. Okay. Another one is peer education. Educate your peers about the harmful effects of drugs, and also what negative effects that you might get from taking it. Also promote healthy lifestyle. Okay, eat healthy. That's what I always advise my students. So promote healthy lifestyle. So yeah, so let's go to the other. Okay, learners at Lytton Girls Senior School watched a simulation of Rutherford's gold foil experiment during a chemistry lesson. Question A, describe 2 observations made in Rutherford's experiment. Now, Rutherford is a scientist who discovered how an atom looks like, what are the particles inside an atom, and etc. So he said that there was a particle, let's say maybe beta or gamma particles, that usually come and then hit the gold foil. Tamam. So he discovered that the particles itself, there was one particle that just passed through the gold foil. Okay, the other particle bounced back so it bounced back. That's the second observation he noticed. There was also rebounding back. Some instead of bouncing back, it deflected. So it came here and then deflected. So those are the observations he saw. Tamam. So again, what are the observations once more? So let's say the first observation was, so most alpha particles pass through the gold foil, pass straight through gold foil. Okay, that's the first one. The second one, some particles deflected at angles. Some also bounced back. Okay, now we're coming to the conclusions. There are two conclusions drawn from the experiment. The reason why the particles passed straight through, he concluded that there was an empty space in an atom. So empty space in an atom. So let's say atom is mostly an empty space. An empty space. That's why the particles just pass straight through. Because if you look at an atom, let's say this is your gold foil and the particles pass through. So obviously there's space inside that atom. So most of the atom is just an empty space. That's the first conclusion he came about. The second conclusion, he said that since some particles bounce back, so it means that ime bounce back kwa sababu kuna nucleus katikati. Nakumbuka hii ni positive and the particles are also positive. That is why it bounced back. Same particles usually don't attract, they deflect. Tamam. So he concluded that, that first thing, the nucleus is small and positively charged. Otherwise, it can't, the particles won't have been bouncing back and positively charged. So fasting, there's also another aspect as well. The reason why it deflected, okay, and the reason why it bounced back is mostly the same reason. The reason is just because of the presence of the nucleus, okay, and the nucleus being a positively charged subatomic particle. Yeah, so let's continue. Question C. Name two subatomic particles found in an atom, that is protons, and the other one is neutrons. But for now, because of Rutherford's experiments, we can say the electrons, because he didn't say anything about neutrons. But usually we have three subatomic particles: protons, electrons, and neutrons. Okay, but to be on a safer side, just state the protons and the electrons. Question 6 now. Now, question 6. The table below shows pH values of solutions A, B, C, and D. A, pH of 3.0, B 13.0, C 8.5, D 7.0. Sasa pH ni pH is just an indicator to show that a substance is either acidic or basic. So ni kama value tu, kama ni 7, obviously you know it's neutral. So anything that is 7 is neutral. Anything above 7 is usually acidic. So let's say not anything above 7 is usually basic. So from 8 to 10, most of it is a weak base. But if you go from 11 to maybe 13, is usually a strong base. Anything below 7 is usually acidic. So let's say 0, 1, 2, 3, 4, 5, 6, and 7. So from 4 and 6 is a strong weak acid, and then from 1 to 3 or 0 to 3 is a strong acid. So acidity usually increases if you go left, basicity usually increases if you go down right. So yeah, identify a solution which is strongly acidic. So we said 11 to 13, and that solution should be B. So because it belongs to, it has a pH of 13. Strongly basic, obviously again, sorry, strongly acidic is not B. Sorry for that. We said strongly acidic ranges from 1 to 3, so most probably is A. Strongly basic is B. So anything above 7 is a base, anything below 7 is usually an acid. From 1 to 3 or 0 to 3 is usually a strong acid. From 11 to 13 is usually a strong base. Tamam. Let's now go to the other question. Okay, question 7. A teacher at Miranda Senior School stated that element X has two isotopes. X1 has a mass number 35 and an abundance 75%. X2 has mass number 37 and abundance 25%. Define Roman 1 atomic number, Roman 2 mass number. Now, an atomic number is just the number of protons in an atom or in the nucleus. So the total, let me write here, the total number of protons in the nucleus of an atom. If you write in an atom is also correct. The nucleus of an atom. Now mass number is the sum of protons and neutrons in the nucleus of an atom as well, or in the atom in general. Nucleus. How did I write nucleus? Is it correct? No, not correct. Nucleus. Oh, sorry. Neutrons. The sum of protons and neutrons in the nucleus of an atom. So yeah. Question B, calculate the relative atomic mass of element X. Now, how do you search it up? Percentage abundance times the RAM. So let's say RAM 1, percentage abundance 1, plus percentage abundance 2 times RAM 2 divided by P1 plus P2. Now, this is not a relative atomic mass. This should be atomic mass as well. Now, for this one, mass number 35 and abundance 75. So let's search it. Mass number 35, percentage abundance 75, 75 times 35 plus, so we're done with this and this, plus 25 times 37 plus 25 times 37 divided by the total percentage, which is over 100. So let's see how much it gives us. It gives us 75 times 35 plus 25 times 37 divided by 100 should give us 35.50. So yeah, that's the relative atomic mass, RAM. Now, define the time isotopes. Isotopes are atoms of the same element, okay, with different mass number but same atomic number. Yeah, so there are atoms. Let me write here. There are atoms of the same element with different mass number, just like you've seen there, but same atomic number. That is different number of neutrons but same protons. So ukiona hapa mass number ni tofauti, lakini ukishtukizia atomic number is most likely the same because the number of protons doesn't change, but the neutrons changes. That is why the mass number changes. So question D states uses of isotopes is used to specially treat cancer patients. We use that, treat cancer. Also used for medical diagnosis. Okay, so treat cancer. Also, what else? We used in dating rocks, especially the carbon 12 and etc. So dating rocks, it helps us to know this rocks comes from which century, how does it look like, how is it different from other rocks, and etc. So yeah, okay. The grid below shows part of the periodic table. You use it to answer question that follows. The letters do not represent the actual symbols. Now, question A, give the name of element S and also element W. Now, this is hydrogen because it's 1, then followed by helium, 1, then this is 2, obviously. Then this is this is lithium, beryllium, we have boron, we have carbon, we have nitrogen, this is oxygen on Friday, this is fluorine, is this nitrogen really? 1, 2, 3, 4, 5, 6, 7. Yeah, nitrogen. This is neon. And then this is sodium and A. So sodium. So this is magnesium. This is aluminium. This is most probably, I think, 1, 2, 3, 4, silicon. This is phosphorus. Yeah, it is phosphorus. So how do I know this? From the acronym. Hey, listen BBC News on Friday night. Somali minister accuses Somali president, saying this might be sulfur. 1, 2, 3, 4, 5, 6. This is calcium, most probably. 1, 2, 3, 4, 5, 4, 5, 6, 7. So this is 7, group 7. Group 7. So this is chlorine. Sorry. So there's a lot which I can say. Tachoka. So there's a lot. But now, if you look at element S, most likely element is which one? Element S. S, S, S. This is S. So this is in period. Period. This is periods 1, 2, 3, 4. So period 2. Which group? Group 1, 2, 3, 4, 5, and 6. Group 6. So most probably this should be, because since it's in group 6, so most probably it's 2, 6. And 2, 6 is 2, 6, 8. is oxygen. So name of element S is oxygen. Okay, because if you look, it's 2 6, and so it's 8, and the element that is number 8 is oxygen. Tamam. Now element W, again, this is 7, this is 8, group 8, period 3. Period 3. So most probably is 18. Most probably this is 288, which most probably is argon. So element W is argon. So yeah. Now question 9. The electron arrangement of an element Y is 2881. Identify the period and group of elements Y. Now the period is the number of energy levels. So the number of energy levels are 4. 1, 2, 3, and 4. So period 4. Group, you look at the last electron in the outermost energy level, that is 1. So it's group 1. Make sure the groups are written in Roman numbers. So yeah, that's easy. Identify the element. Is it potassium? It is potassium. Which is whose symbol is written as capital K. State the chemical family to which element Y belongs. It's called alkali metals. Alkali metals. Alkali metals include sodium, we have lithium, and we have potassium. Okay, alkaline earth metals. Earth metals include magnesium, have calcium, have beryllium, and etc. So that's not hard, is it? Nope. D. Predict the type of ion formed by element Y and explain why. Now the type of ion that's formed by element Y is K plus. Okay, it's K plus, right? So it's a cation. It's a cation, and the reason why it's a cation is because it loses one electron to gain stability in the outermost shell or in the outermost energy level. So it loses one electron to gain stability. Since it has only one electron outside, so the only thing that it can do, it just loses that one electron. So yeah, let's go to the last question. Sorry, we're not done yet. I'm thinking of a last question. Question D. State two reasons why noble gases are chemically stable. That is because it's full. The outermost energy levels are full. Energy level or outer shell is full. And the other one is cannot gain or lose. Cannot gain or lose any electron. That's why it's stable. Now, question E. Give an example of an element under the following category: alkaline earth metals. We just said it right now. Magnesium, halogen, we have chlorine, we have fluorine, we have iodine, noble gas, argon, we have xenon and neon, and etc. Okay, let's go to the last question of the question 10. A. Write the electron arrangement S and P notation for the following ions. Now, Roman 1, sodium ion, Roman 2, oxygen ion. Now, this is very easy. Usually, you draw something like this, just in case you don't forget. 1s, 2s, then we have 2p, we have 3s, we have 3p, then 3d, we have 3p, we have 3d, and etc. There's many, but for now you just need to know, but we have 4s, 4p, 4d, and 4f. Okay, but now how would this help you? Now usually you do something like this, where you go this way, then this way, then this way, and etc., then this way and this way. Okay, so that's the way that you usually use. That is 1s, 2s, 2p, then we have 3s, then we go to 3p, then 4s. Okay, but that's enough. So just know this one. For the s orbitals, they just take maximum of 2. For the p orbitals, they take a maximum of 6. Just know that s orbitals usually take 2. Okay, now we know that sodium is number 11, therefore it has 11 electrons. But now sodium plus will have 10 electrons because it loses 10 electrons. It loses 1 electron, therefore it will just remain to have 10 electrons. So now how do you draw it? Right, how do you draw the s and the p orbitals? How do you draw the electronic configuration using the s and p notations? Very easy. Now you know that for the first orbital it takes 2, so obviously it has 10 electrons. If you subtract 2, you still remain with 8. Okay, so for the second one, which is 2s, it also takes 2, so subtract 2, remains with 6. For the other one, which is 2p, it takes a maximum of 6, so if you subtract 6, it gives you something like this. So it gives you 0, so that is your answer. Tamam. Now for the oxygen we know that it's under, hey listen, BBC news on number 8, so it means it has 8 electrons, but since it's O2 minus, it gained 2 electrons, therefore it's going to have 10 electrons as well. Tamam. So again, it's just the same, because if we look at sodium, it had 10 electrons. For oxygen also, to oxygen 2 minus, it has 10 electrons, therefore you write the same thing. So this is your answer. Not that hard. Now question B, using valency or oxidation numbers, write the chemical formula of magnesium chloride and Roman 2 aluminum oxide. Now magnesium, if you write it in iron form, is supposed to be written as magnesium 2 plus. The valence is just 2. Chlorine is written as Cl minus, so therefore the valence is just 1. So the magnesium will take the valency of chlorine, and chlorine will take the valency of magnesium. So magnesium will take the valency of chlorine, and chlorine will take the valency of magnesium, which is 2. So as a result, it will be Mg. Make sure your M is not this way, but it should be this way. Tamam. So MgCl2, and make sure your chlorine doesn't look like this way, which is very wrong. Now aluminium oxide. Aluminium is 3 plus, oxygen is 2 minus. So aluminium takes oxygen, oxygen takes aluminium. So aluminium will take the 2 and oxygen will take 3. So it's written as aluminium 2O3, Al2O3. Very easy. Now let's finish up with the last part. Balance the following chemical equation. We have iron we have oxygen. This is solid, this is gas, and it gives you solid still. But now how do you balance it? Now for the ion part, we just have one. Oxygen, you have two. On the react and the product side, we have 2 ion, we have 3 oxygen. Right. Now ion is the one which is deficient on the left side. So if I write 2, then you'll have 2 ions, 2 oxygen. But now oxygen is deficient, so let me write 3 here, but it's going to be 6. Now on the right hand side, we have a deficiency of oxygen, so let's write 2. Now we have 6 oxygen, but again we have 4 ions. Therefore, change here and write 4. So the answer is this one. We have 4 ion, 3 oxygen, and 2 ion, 3 oxide. So again, very easy, not hard. And that ends our lesson for today. So don't forget to share and subscribe. So in case you have a Form 4 student who wants to join our tuition programs, tell him to contact me through this number. Okay, it's not free. There's a fee like around 1,500. Easy. But don't forget to subscribe and follow up with this channel. Assalamu alaikum wa rahmatullahi wa barakatuh. Before that, again, once more, I have a playlist for math for grade 10 students. Don't forget to watch that at the end of this lesson. Assalamu alaikum wa rahmatullahi wa barakatuh.